I'm going to demonstrate simplifying complex rational expression using an LCD method. Now, the LCD method was used also when we simplified complex fractions. For example, if you had 5/24 over 10/12. Notice that numerator's a fraction, denominator's a fraction. That's called a complex fraction. What I'm going to do is I'm going to take the least common denominator between the numerator and the denominator. So in this particular case, the least common denominator is going to be 24. I multiply the top and bottom of the fraction by that least common denominator. Simplifying, notice that in the numerator they cancel out and I'm left with just the 5. The denominator cancels and I'm left with 10/2. Or 20. Now I can finally simplify that expression because 5 goes once, 5 goes 4 times, and get my final answer of 1/4. So notice here that all I had to do is identify the least common denominator, multiply, and that sort of cleared the fractions in the numerator and denominator. Well, now let's take a look at a rational expression. X over y squared minus 1 over y, that's the numerator. The denominator, y over x squared minus 1 over x. Okay, now look at this particular fraction here. If you look at the numerator and figure out what a least common denominator there would be y squared. So we got a y squared up here for a common denominator. Down the denominator of the complex fraction, notice that the least common denominator there is going to be x squared. If we multiply those two together, those two factors together, I get the least common denominator of both the numerator and the denominator. Now what I'm going to do is I'm going to multiply the top and bottom by that least common denominator. Okay, similar to what we did with the fractions up before, we're going to be clearing some of the fractions in both the numerator and denominator. Well, let's see what happens. We're going to take this term first, multiply it by that least common denominator, and notice that the y squared cancels, and I'm left with x times x squared, or x cubed. The next term, one of the y's is going to cancel, and I'm going to be left with x squared y. In the denominator, we're going to play a similar game where x squareds are going to cancel, and I'm going to have y cubed minus, let's see, one of the x's is going to cancel here, so it's going to be x y squared. Okay, so now let's look at what we did here. We've gotten rid of both the fractions in the numerator and the denominator. Essentially cleared those denominators. What I'm going to do now is I'm going to take a look at the resulting numerator denominator, see if I can do any kind of simplification here. Let's see. In the numerator, it looks like I can factor out an x squared and left with x minus y. If I factor out a negative y squared in the denominator, what's going to end up happening is that this negative x is going to be changed into a positive, and then I'm going to have a minus y there. So I sort of looked ahead there and saw that if I pulled the negative y squared out, that I'd get some good factors that I could then cancel. Okay, finally, let's rewrite this. Any more simplification? Nope, nothing there. Put the minus sign out front, x squared over y squared. Okay, so this method here mimicked, again, what we used to do in regular fractions, where we would multiply both the numerator and denominator of that complex fraction by the least common denominator of the numerator and denominator. That had the effect of clearing the fractions in the numerator and denominator. And then the resulting fraction, which was a simpler fraction, we could then simplify and express in final terms. Exactly what we did over here when we were talking about our rational expression, except of course the least common denominator got a little bit more complex, and we had to do some algebraic manipulations to get it simpler. But we used the same methodology, ended up factoring out things, canceled them, simplified to write up our final answer.